Hey. It is a Tuesday, which means we are back on that NES stuff. So, as always, it's in the description, but I am thinking today I want to go ahead and fix up the the BIOS interface that I had written, and then let's just chuck that all in the trash. Not chuck it in the trash, we'll save it. But once we have that going, let's discuss whether we should proceed to playing with DOS 65 DOS, I'll have to look it back up, stuff, or basic stuff. The question there being, after all of this futzing around with floppy crap, do we just want to take all of that, put it on the back burner, and go back to the original theme of things, which is getting this thing booting basic, and then maybe we can go back to floppy stuff once we've done that? Or plow ahead with floppy stuff, get 65 DOS working with this gotek, and maybe try swapping the gotek out for a real floppy drive at some point. And then once we're done with all of that, go back and get basic running on this thing as like the default thing. Now, Trade MC says Pong, which is, I guess we'll just do that. Okay, solved. No, anyway, figure I'll do that at the end once more people get online. But for starters, let's figure out what the heck is wrong with this whole system call interface thingy that I wrote. So I'm just gonna do my usual and just look at the code and see what obvious things I screwed up, because I'm sure it is obvious things that I screwed up. Trade MC says, I'm responding to your ping. Nice. Indeed. Ping and Pong. So, anyway, actually, let me refresh my own memory here, because I have none. Let us get ourselves some power. Can we have that? Yes, we can. And we should be, disk 0 on here is the actually bootable one. And it would appear I need to reset my video capture thingy. Hold. Okay, let's try that again. There we go. Right, so right now it's just hanging. That's all it's doing. Which, cool. Let me also pop this out and double check that it is in fact attempting to do the breaks and therefore do the system calls. I have run out of USBs on the back of this computer. Okay, let me just open that on up in XVI 32. Open with something. Please give me options. Anything is good. Responsive. Okay, yeah, that's got all my zeros, because break is 0. Let's double check that as an obvious thing. I am quite sure that was correct, and break is in fact 0. Ooh, you know what we can do? That's real easy. Go to the... Oh, well, actually, I guess I could just do BRK assemble. It's going to be 0. It's going to be 0, 100%. Ensemble. Cool. Why, look, it's 0. So if my code was supposed to be... You know what I can do? You know what I can do to debug this? Is I can totally skip and ignore all the floppy shit right now. Just jump straight to... Or instead of loading a sector, let's skip over the loading a sector part really quick, and we will just put this code in the ROM, and then we should be able to load it into FCEUX and debug it that way. And that should be fine. So, where shall I do that? Let's just jam this code up here, which is supposed to be BRK followed by... How did this work? So it was 4-byte payload, right? So it was like BRK, payload. Oh, no. BRK, command, payload. That's right. Which actually might be part of my issue here. Interesting, actually. Because, yeah, it was supposed to be BRK and then 4... No, it was 4 bytes, right, and then the first one was the command. It wasn't a command and then 4 bytes. Theoretically. That's what I think, actually. So, BRK, 4 bytes, BRK, 4 bytes. That should be it. And those bytes are... 0, 0, 0, and 0, and that should be our, I believe that's our little test print hello string command, followed by BRK, same thing, byte, 0, 1, which is our re-enter monitor command, 0, 0, 0, 0. I'm pretty much wasting time here because I'm never, ever, like, this is gonna go away real fast. But I'm just, for fun, I just want to make it work. And that's, I'm just here to have fun, man. So, anyway, there's our, oh, I should add a label to this. Test, or let's call this BIOS test code. And what we should do now is do all the regular initialization stuff. MMC3 stuff. Here we go. Here's FDC stuff. So we're going to do init keyboard and then that doesn't really matter. Yeah, I'm just going to jump over this whole thing. So temp remove jump skip read sector and where shall I go from here? Actually, I guess really I should just jump straight to that code, right? Like I don't need to go anywhere else. Otherwise I would be entering the monitor, but if this worked, it would be jumping into the monitor anyway. So yeah, let's just jump straight to our test code. BIOS test code, and that's that. We should never come back here if things work at all semi-correctly. Yeah, so if I build this and load it up in the emulator, that should at least hit a break and see where it goes and figure out why the code is all garbo and stuff. FCEUX, come on, my friend, let's figure this out. FCEUX.exe. It's the finest emulator I can see. Okay, and it takes poop. That's fine. I wonder where it is. Doesn't seem to be doing anything, which is rather interesting. So let us pause. Emulation speed, paused. Reset it. And then I need to figure out what my breakpoint is going to be. Where does this start? E1000? E1000. And I guess I can just look for break crap. Where Worm says it's gone buying some milk like Dad. You think that's what it is, you know, Dad didn't abandon us. He just got stuck in a loop trying to get some milk. His stack overfloweth. This looks like my init code. Oh, wait. This all looks kind of weird. I bet these are tables and stuff. These are probably tables and stuff. That's right. I'm still way off from where I need to be. Nope, this still looks weird. Why does this still look weird? E1000 is where my cartridge starts, right? So why does it start with an exclusive OR? Oh, because that's not where the... Right. That's not where the entry point is. I always forget this. The entry point is not E1000. That's just where the code starts. Yoodly doodly doo. And anyway. So what is that test code supposed to be right after? It's supposed to be right after all of the strings, which should pretty much be at the start. Yeah, these are all declarations that don't actually take up any code space. So it should be pretty early on. Oh, though, you know, it might not be aligned, so that's an extra fun thing. Because if it's not aligned, then it will have no idea that that is a break. Well, aligned with what it thinks the code is supposed to be. So that's cool. I didn't think about that. So this still all looks like strings. String, data. This looks all like potentially still string data. Then lots of zeros for some reason. Oh, it'd be nice to know how to do that export table. That would be quite nice. Oh no, yeah, this has got to be it, because this is clearly the start of my code, and here's that 01000000. So I am looking for, let's see, that is the fourth payload, third, second, first, and the actual break. So I'm not sure what the double zeros are about here, but this should be my entry point, I believe. I guess I could have just seen what the jump jumps to. That would have been way easier. Whoops, too late. And does it even do it? No, fascinating. Okay. So let me actually set a breakpoint at where it actually is doing the call into there. Looking for jumps, looking for jumps. This is setting the scroll. That I scrolled past. That's... Oh my. Thank you for being awful, debugger. Okay, here's my start of code. No, I want to get hacked. I want to get maximum hacks. Thank you for being so stunningly unresponsive. Yeah, there we are. So these, all of those PPU datas are this. Oh, there's still a bunch past that. Okay, let me... A1001 and then a JSR jump. A1001. And then a JSR and a jump. Where said, lots of zeros is what you're looking for. Yeah, yeah. I found them. Let me tell you what. Why is searching through all of this such a pain in the ass? Okay, I'm probably going to want this later, so let me just finally look up how you actually frickin' create a symbol table. CA 65, yeah, 65, dump symbols. So it's just gonna take me back to the page I was already at. Sick. I guess command line options overview. Oh, actually, it would probably be the linker that would give me the list of everything, right? Because an object file is not going to have anything but virtual addresses in it. Twould make sense. So we actually need to, what is it, CL65? Create a map file, -m. There you go. That's easy enough. Where is my build script? Here it is. And it's literally just, let's see, is it literally just -m symbols.txt? Let's try that. No. I like bashing my head against things. I do not want to install the extensions for PowerShell. I like it when it's difficult. All right, it did not complain. And it looked, yeah, there we go. Sweet. Okay, so it dumped my modules and segments. Sick. Thank you very much. Yeah, probably just erased my labels, huh? I mean, oh, you know, -L might be good enough because that'll give me symbols and locations. Let us see. Let's do -L. Assemblyist.txt. Let's try that. Cool. It says that's not an option. Yep, it's definitely an L. Awesome. I appreciate it. I mean, I guess it's rather annoying because I don't know if it erases symbols when it makes the object. Like, if they aren't exported, it just erases them. That would be... Patrick Burke said, I wish I know how to learn this stuff. You're watching me. That's what's happening right now. I got no friggin' clue what I'm doing. Wareham said, need -G on the assembler? Maybe. I mean, I don't think it... Is it just -G? Let's see. It literally is just -G. Let's see. That's not a bad thought. -G. And then, same thing we had before. What was it? -M. Symbols.txt. See if that does a better job of not erasing things. Nope. But I guess I can probably... How do I export a symbol? Is it like .global? Like every other reasonable assembler? Let's find out. Uh-huh. Okay. That didn't do shit. Still didn't do shit. Okay. Awesome. Dash VM. Is that a thing? VM. Ah, verbose map file. Look at that. I don't know if it is, but it's a better guess than I've got right now, which is none. Okay, I love how these don't line up. Oh, wait. CL65 is for compiling and linking. I'm using LD65, which is the linker. I see. LD65. There we go. That's why I didn't know what those were. Command line option overview. Do. Okay. I mean, it still says VM should be an option. So, but oh, do I need them both? I might need them both because VM doesn't look like it takes the name, so I might need M and VM. Let's find out. Come on, you can do it. You can do it. There we go. I don't know why it wouldn't list the exports in the first place, but it's at EO65, so we can just set our breakpoint to EO65. There you go. Did I just close the debugging window? Apparently. Wow, I already forgot. Well, what was it that we said it was? EO65. Oh, I was so close. I was off by one. I thought I might be. Yay, there we go. Okay, I am unsurprised that everything up to that point worked. Now, let us see what happens when we hit this break. Okay, E6AB, PLA-TAY, and an AND. That looks right, but let's go to the actual code, which is way the frick down here. Init keyboard stuff, get key, print character stuff. Here we go. IRQ break handle. Yep, that's the one. And we are ending with 10 because that is where the break flag should be. So we should hit that and hopefully not branch to handle IRQ. Very good. Okay. So we store some values. Yes. Let's see. So these are theoretically. We just stashed our stack pointer. And then the address we were going to return to. So let's see. EO67, that seems right. And this was, let's see, store Y. Ah, yes, because we were pulling the status register status. Oh, right, sorry, that's not stack register, that's status register. Right, so pull A to get that value, then stash it temporarily in Y, and it with 1, and then go down here and grab stuff. Cool, so that works. So this should be, so 36 is the status register setting. All right, everything looks okay, and that E067 address looks reasonable. So let us find out why this is being shitty. Okay. What's the best way to do this? Like this, maybe. Maybe. Just want to be able to see the source and this at the same time. Okay. So load 1 into Y. Load A, the low break address. Or no, the whole break address. Yeah. Which is going to be E068. So that math checks out. And we are loading the first argument, which is 00, which seems right. E068, is that correct? I don't know, we'll see. It shouldn't really matter all that much, because it would seem it's having problems like dispatching the function in the first place. Okay, so we shift that left, right, because our whole table is 2 bytes wide for every entry, which is just 0. And then we clear carry so that we can add 0 to it, apparently. Ah, yes, because the command table is indeed aligned to a boundary. I did that on purpose. Then we store it at 1F, because that's where we're keeping the command address value in 0 page. Then we load E7, which is the high byte of the command table start address. And then we just store that in the high part of command address. Right, because of the alignment. So really, the fact that I'm adding it all is kind of dumb, because it's always going to be aligned. So it's always going to be 0 plus whatever it is. So I should really just make the command address low part the value, and that's it. Well, you live and you learn. Anyway, regardless, that should make the command address is E700, and what's at E700? Hopefully that's our table, and hopefully that's the jump into the print routine. Yep, so here's the start of our whole thing, and that's interesting. We have an E2 and then E6DF. So did I screw something up there? That could be a what's up. So this is supposed to be the start of the command table. And command hello is supposed to be what the first word there is, but is that right? Let's see, it's E2. Weird. Because it would be E2, E6. E6, which would be E6, E2. Actually, that seems reasonable, because if this is E700, then going back just a little bit and being in the high E10s, however you want to say that, E0s, the high E0s, would make sense. Okay, so that seems fine. Oh, but we're, yep. It's that we need to be doubly indirect here. That's what the problem is. Ooh, that's hairy. Because what it's going to do is it's going to jump to E700. I want it to jump to E6, E2. Haha. Is there an easy way to do that? I know not. I mean, I can definitely do it like in software, because if I like look up the value that's there and copy it somewhere else, and then do it. That would totally work too, but that's slow. Just make the table jump commands. Wereworm, you are so right. Oh, the only problem is I can't do my... well, I guess I just make them 4 wide, and then I can just left shift it twice. Not like it matters. I'm going to throw this in the trash anyway, so... yeah, that's why it's a jump table. So yeah, for all of this, just replace... oh boy, let's see if I can remember how to do my blocked stuff. Shit, how do you enter block mode? I have forgotten. I thought it was Control-Shift-V. Is it just Shift-V? No, it's not. Control-V? Yes, Control-V. Sick. And... yes, okay. Yes, I'm getting okay at Vim, guys. Watch me go! Patrick Burke says, ask an AI code generator. That Wereworm is an AI code generator. Sick. All right. I guess that's that. And now, the magic is just that I need to... here, IRQ brake handle, ASL twice. Not that it matters because it's still going to be 0. There we go. And now that jump will jump to a jump instruction. Oh shit, and I need to pad every single one of those. That was my second thought, was that this is going to be 3 bytes because it's going to be the 2-byte address and the 1-byte jump command, but they all have to be followed by that shit. So that's fun. But anyway, that's actually not so bad because I really only have entries for the first 2, and then for the rest of them, I can do this, and then T2W, nope, T2D, and then let's see. So I have 256 bytes available. Divide that by 2 is 128.64. Minus 2 entries is 62. So I need to paste this 62 times. 62p. Cool. Now I just need to delete the rest of the stuff that I did not get rid of. Yay. All right. This should be a thing. It's gross. It takes up a ton of memory, but I'm not fussed. Let's restart. Let's restart. Let us restart the whole dang thing. All right. Still didn't do anything. Super cool. Oh, I probably need to reload this. That would make sense, right? Not like FCEUX is going to do that out of the goodness of its heart. Let me fully restart. Hello, Lawless. Patrick Burke says, it's a jump to instructions mat. It has different instructions on it that you can jump to. Excellently executed. I could not have done better myself. All right, let's just see if it goes. Huh. That is subtly wrong, and I like it. I also like how it just kind of goes insane after a while there. Of course, that's potentially because... is it totally random? I was going to say it's potentially because my line printing code isn't actually that good. But... yeah, it just kind of decides to glitch out there. You'd think it would be... I was going to say you'd think it would be, like, reliable, but you know what it might be? Is that some of my breaks are getting eaten by IRQs. That would be funny. Because I don't know if I turned IRQs off on the video card. Video chip. Whatever it is. Anyway, that's close. So I think now... My guess is it's probably just not doing the stack reconstruction properly when it's done. So that's the next place to debug. Let's see. So I guess break complete. Let's make this global. Using our fun new trick. Dump it. Set a breakpoint there. I'm sorry. 1369. Oh, yeah, it probably wants to know what is global, right? No. Break complete. There we go. And there we are. Break complete is... Huh. Excuse me. Why is that in... Oh, it prints 2 columns. I'm just blind. Nice. E6CB. Oh god. I killed FCEUX. Did I not? File open. Basic.NES. NES? NES? What are the opinions out there? I'm surprised I haven't asked this already, because, like, it's controversial. It's divisive. Apparently, a lot of people say NES and SNES. Wait, what do I say? Is that what I say? No, yes. That's what I say. Apparently, a lot of people say NES and SNES. Apparently, that's the way. I always said it with like a Z sound. NES and SNES. And Trey says NES, which, yeah. Wareham said, or the normal IRQ jumps to print. It's possible, but that code is supposed to be checking the break flag and just exiting. Back to the caller. Of course, it might be doing that wrong, but interesting thought. Let's just see what it does, because we can just put the breakpoint in here, because we know what that is now, because we're smart. E66B. Or at least smarter than we were moments ago. E66B. Right? No, A6CB. Wow, good job. E6CB. Execute. Okay. Reset, please. Wait, no. Run, please. Oh, shit. Shit. I have backed myself into a corner. Because you can't, when you reset, it does not clear. Oh, wait, no, it did. Okay. I thought it didn't, reset if you were on a breakpoint. Didn't reset until you run. Okay. Interesting, firstly, that... Now, it may just be... It's probably because the video card hasn't updated yet. That code probably hasn't triggered in the emulator, because there's supposed to be an exclamation mark. But we definitely saw that printed, so I don't think that's worth being concerned about. But back here at the code. So we clear the carry bit, and we load the low byte of the return address, and we add 4 to it, which is probably wrong. We can check real quick though, because let's see. So that would be E whatever 6B. Oh, whatever. It'll show us in the debugger. Add. Okay. So now. Oh, I have to look. Cool. Not cool, but cool. What is it? 1D and 1E? Oh, let me actually use. There is a memory viewer. I don't have to use the debugger. That would be silly. debugger hex editor RAM. There we go. Okay, so that is at 1D and wait. What? Hold up. That might be part of your issue. So we load the low byte, add 4 to it. Wow, was I high when I wrote this? So we stashed the low one in Y because, and then we would want to load the high break address, then add that, but yeah, what the hell? What the actual hell? Load a BRK adder +1. There we go. Then add 0 with the carry to that. Then push that. Then push the Y value. And hopefully... No, load A. There is no way load A is going to set the carry flag. I'm feeling more confident about these lately. But yeah, that'll do it. And then we're probably just going to some weird location in memory that is probably full of zeros and triggering a bajillion breaks. If I were to guess. Yeah. Let's give that a try. Kill it. Kill it with fire. fceux.exe. File open. The thing. Right here. Open. Oh! My God! I'm sorry for any epileptic viewers. Let's just pause this right now. I'm wondering if maybe it's because that enter monitor code is bad now. Let's see. Is that breakpoint still good? No. It's probably going to be one further out, but let's just actually look because we can. Oh, it actually is E6CB. Let me make sure. E6CB. It did not move. All right. Cool. Well then. Reset. And run. Okay. So. E046 was where we were going to return to. Oh, wait. Wait, no. Yes. E067 was where we were going to return to. There we go. And so we load the 67. We add 4 to it. We stash it into Y. We load the E0. We would add a carry bit if there was one, but there is not. Then we push the high, transfer, push the low, then load the previous status value, and then push it. And is this a reasonable stack? Stack? I don't know. I hope so. We'll find out in just a minute here. RTI. Cool. So that did... Oh, wait. So that is off. Interesting. I'd imagine probably because this is off. Like, it was jumping to E067, right? But I feel like it should be jumping to E066. Because it needs to the break, and then 1, 2, 3, 4. But if it's at E067, then it's just the break, and then 1, 2, 3... And that's why it's here when it should be here. Yeah. So, what's up with that? Let's look at this table again, because we can. BIOS text code is E065. BIOS test code, sorry. 1, 2, 3, 4, 5. Okay, so it actually is all the way back here. 1, 2, 3, 4, 5, and then, no, sorry, right here. 1, 2, 3, 4, 5. Then the next break command. So we're just one too many. Which is okay, I guess. I still, because the return address already had one added to it when it got pushed on the stack. That's why. That's why, you foolish man. So we don't need to add 4, we only need to add 3, and hopefully that will solve every problem that we have ever had in our lives. Emotional, psychological problems with our families and significant others. Hopefully we're all just solved via that single line change right there. If we're lucky. I'm telling you, if we're really lucky. Do it. Okay, still wrong. But now it's wrong in a fun, different way. So let's keep on going. Let's go ahead and pause that. And let's go ahead and go to the debugger. And let's make sure that E6CB didn't move. It didn't. Okay, let us oh, well, okay. Step over, step over, step over, step over, step over, step over. All right, so now our stack is EO6A is where we will be returning. Oh, I probably need to add even fewer though, because, well, no, because it was at the 1, so it should be one more behind now. Should be. EO6A, 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 EO6A. We'll get there in time. EO6A, yeah, there we go. Okay, so maybe that is fine, and then this is all effed. Yes, that is quite the possibility. Let's keep on going. Step into, yep, there we go. There's another break, which is cool, because that means, I mean, just like the fact that we did our little, like, read a block of parameters and then just jump over the whole thing, I think is really dope. Okay, now we're back here again. And I guess I'm just going to let it run because it's the next thing it's going to do is hit that same breakpoint if everything is right. And if things look significantly weird when I go to do the return here, then we will know what's up. Actually, wait, no, we never should have gotten here. We never should have gotten here because that command is supposed to enter the monitor. Haha. Okay, so actually let me reset and run, because the question is actually why didn't it go back into the monitor? And I see it printing hello again, so my guess is that the dispatch isn't working quite right. Probably because our whole thing is off by 1, right? So it's probably reading an argument of 0, and then it's effing off into space in the ROM. That's almost surely what's up. So when we are loading our arguments here, well, our argument, I actually do want 0 here, because that's pointing 1 ahead. Yes. And we want it to be pointing just 1 ahead, whereas that would be pointing 2 ahead. Really is a bummer, though, because that was the one that, if we solved it, would have, I'm pretty sure it would have solved world hunger as well. I said it would solve all issues that we've ever had. This one, not going to do that, which is really, really a bummer. We don't get anything for that one. So, I mean, you know, at least things didn't get worse. Somehow that is doing the exact same thing. That's totes cool. Oh, I guess let's just step through it. Let me export this bad boy. So that I can put a breakpoint there. And that is E6AB. Oh, I guess I could have just put a break at BIOS test code like a smart person, but whatever. E6AB. Poor crying baby. Okay, pause that shit. Debug, debugger, breakpoints, add, whatever that number I just said was. E6AB. 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 Okay. Reset. Reset. And run. And there we are. And so the first one I don't care about. I care about the second one. There we are. So when I get here, this should hopefully... Wait. How the hell is that supposed to work? Okay, yeah, no. So it was supposed to save. Yeah, break address should have the address of the thing. And then this should load. Yeah, okay. So after this, A should contain, if everything is sane, it should contain a 0-1. Which it clearly is not, so. What's in A? It's 0-0. Super neat. All right, so this says EO6C. Actually, what does it say EO6C? Is it because this addressing mode is totally friggin' wrong? Probably. Is it because it's supposed to be the one that indirects before, or the other indirecting one where it's inside the parentheses, where I still don't know how to describe that, but it's the different one, because EO6C feels, actually that doesn't feel crazy wrong. Let's look at EO6C. Because that's in the beginning areas of the ROM where, like, things should be. EO6C. EO. Yeah, this is not the way to do it. This is terrible. EO6C. EO6C. Come on, get past the D's. We can get there. EO6C. EO6C. So EO6B, EO6C. Okay, interesting. So, why is the break address out that far? That's my question. Nope, that's not what I want to look at. Let me look at this. Let me look at the hex editor. No. Let me look at the... No. Let me look at the hex editor. There we go. Thank you, fingers. All right. So 366C, that is what is stored there, which would make sense because you add 0 to that, and it's 36 or no, sorry, E06C, right? Yes. This is 1E and 1D. Right? I'm not looking at it anymore. Whoops. But yeah, I believe that was right. So why is it so far out? I would expect that what we would have gotten off the stack was 6B, if anything. Why would break? I mean, break doesn't take an argument, does it? Does it? Does it? Am I insane? Does break take an opcode? No, right? No, because I just assembled it. I just assembled a single break statement, and it just assembled to 0, with no operand, so... Huh. Anyway, so that's funky. That's quite funky. Quite funky indeed. Is there anything I'm doing that would cause that? Regardless. The thing here is... I get... Because I could just add, like, FF to it. I could. It would wrap. It would do the right thing. It's just weird. And I'm throwing this away. I'm throwing this away. Let's not worry about it too hard. Let me read chat. Firstly, Patrick Burke said Famicom because it was it Famicom everywhere except for the US? Like it was Famicom in Europe, right? Because it's the Super Famicom in Europe as well, right? Trade MC says you were high and low. And thinking back to my younger days, I'm pretty sure my friends and I called it Nintendo. Correct. That is the one true name. And then Werewolf says, sorry to all elliptic viewers. Trey said, I'm ecliptic. Oh, the NES never came out in Europe? I actually did not know that. I always assumed that it did. Huh. Well, that makes some things about people's love for the... I always hear, well, not always, but I conspicuously have heard more about people from Europe loving the SNES or the Super Famicom, but I never hear anything about the Famicom. Never really thought about that until just now. No, it was called NES in Europe. Well, yeah. Oh, you're saying no, it was called the NES in Europe. Okay, yeah. So it was the NES and then the Super Famicom? No, right? No, I don't know. Anyway, let's just add FF, like a moron. Because I was only reading chat to see if anybody had any thoughts on why it would put out the return address by 2 as opposed to just 1, but no one's telling me. And it was Super NES. Okay, so, yes. All right. Then that revelation I had, it was a lie. It was a lie. And now I look like a dummy poo brains. Yeah, that's probably what I'm thinking of, because Patrick Burke says Super Nintendo, but it has the Super Famicom form factor. That much I knew pretty much for sure. That it had the Super Famicom form factor. Uh-huh. So it got intriguingly worse. I'm amazed I have not cracked this yet. Like, this should not be this ridiculous. Anyway. Run. Okay. What I care about... probably that FF is still not right. Oh. Yes, the question there is, because I'm thinking of it in terms of just adding, but the wrapping would have to work right, and possibly it does the addition correctly there. We will have to see. Yeah. No, okay, cool. It does wrap like I would expect. Right? No, it adds it correctly. That's a pisser. Frickin' frack. That is so odd. Okay, let me reset this really quick because I am curious when we... Okay, so like for par example, we know that first one was... Yeah, it goes ahead by 2. Why does it go ahead by 2? Because I know that first break is at E065, right? Because that's where BIOS test code starts. So that first break is at E065. Subsequently, or is that still things being off? I don't know. That's quite funky. 1 second. I am getting messages from a distant voice. Dinner time. Dinner time is coming up. But anyway, so whatever. Just F it. Just F it. Just F it. F it. Just F it. That is quite... Okay, I'm going to reset this. I'm going to put a breakpoint also at EO... What is that? EO65. EO65, execute. Okay. Reset the whole dang thing. And at EO65, right? That seems right? That would be... That seems okay. So it's our break, then our parameter, our command name, then parameter. And yet, what it is putting on the stack is EO67. I would expect EO66. But watch this happen. So it's definitely at EO65, and yup, it just does that. That is weird. Well, I guess we'll just call that first one, that first byte, a loss, just to make this work, because time's running out, and why am I even fussing with this? So let's just go over here, and let's just change our shit all around. Change this back to 0. Yeah, if anybody knows off the top of your head, Trey says nothing like calling your SO a distant voice. SMH. I'm sorry. Offensive. I shall atone someday. It was up here, right? Yes? Yes, here we go. So, as mentioned, let's just F it. All I'm gonna do is move this over here. And if that doesn't work, I'm gonna eat my own face. Live on television. You don't think I can do it? I can pull it off. There we go! Yay! Okay, so now the real magic comes in when we go ahead and go to... Do I still have the... Yeah, I still have the drive plugged in, right? Yeah, cool. So let's delete this. What was that called? BIOS, test code, delete this, delete all of my things that are called global. Delete that. That's all of them. Yay! Now, I need to burn this chip and update the USB to use the actual calling convention that I have just now on the fly updated, and then we shall boot it, and then a quick conversation about what to do next, and then I will go get some din-dins. Yummy din-dins. Trey said, don't apologize to us. Okay, anyway. What am I thinking? How is my brain going? Right, I just burned this. I think it's because we've gotten to a place where it's so simple, I'm confused by it not being complicated anymore. Feels like certainly there must be more. No, there is not. Okay, thingy in the programmer. Clicking on the programming button. Clicking on the other, more effective programming button. Clicking on the back button. Popping this out, putting it in the other thing, not showing you because why not? Just trust me, it's in there. I'm not pulling a magic trick. I am not pulling the wool over your eyes. And back to XVI32, which should have the disk image open. So I shouldn't need to do anything with that. And there's our break. Command, 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 command. Break. Garbage byte. Command. Is it saving to the USB stick? It's saving to the USB stick. Amazing. It has saved to our floppy drive. All right, are you ready? Are you guys ready for camera 2? Because, yeah, we are actually going to use some camera 2 today. Oh, and then we wait 3 days for the gotek to boot up, because that's the way it is for whatever reason. Okay. You better just work. Yay! I mean, I should have put a line break there, but whatever. There. I mean, we were doing it before, but now we have executed code off of our floppy drive that could then ostensibly boot up more stuff, like transition DOS 65, 65 DOS, whatever it's called. So, reading data from floppy via a syscall? No, but I should add like a sector read syscall. Well, here's the thing, is all these syscalls are probably going in the trash after all of this work. I just wanted to do this for wrapping it up and having fun's sake. Yeah, no, it's still just the read sector routine is not a syscall yet. We could make it one. I would have to allow it to, because right now it just always reads sector 0. It's hardwired to do that. So it wouldn't be a very useful syscall right now because we just read sector 0 again. And also we'd need some more fun params because it will overwrite the executing code because the code is executing right out of the sector buffer right now. So we'd need like a separate buffer or to relocate the code somewhere. But anyway, here's the thing. For anyone still watching, before I get the F out of here, we have, as I see it, 2 routes forward right now. We can either... now, either way, I'm ignoring the hardware floppy drive for just a minute because we wasted so... There are almost 10 episodes of me just trying to figure out how to get the damn thing working. So I want to take a nice hefty break from that and do something that is actually getting stuff done. And then we'll get back to it. We'll get back to it at some point. Choose your own live stream. Yeah, it's called engagement. But we can either go and play with DOS 65, 65 DOS, whatever it is, or go and play with BASIC. I'm not sure. We're having so much fun doing floppy stuff, and it'll give us reasons to implement more floppy stuff. For example, reading a sector other than sector 0. And yeah, could be fun. So for anybody who missed the DOS 65 stuff, let me pull up that site. It's basically somebody made a CPM alike at some point for 6502. And I mean, it seems CPM-ish in that really all you need to do is supply it with a handful of BIOS routines for like read a sector, write a character to the output, read a character from the input, and a handful of other things. And that's it. You're good to go. You have an operating system. Let's see, DOS 65? 65 DOS? So that seems very compelling. Nope, not 65 days of static. Very much not 65 days of static. DOS 65. Here we are. So could be cool, might be cool. It folds into the fact that we've been doing, you know, floppy stuff. Seems like it might be fun. The other option is get back to the roots of what this thing was supposed to be doing and do basic. I'm not gonna pull that up because you know what basic is. It's Microsoft Basic. There's a guy who made a reverse engineered copy of it. That's what I'm going to use, if anything, because it's well documented. It's written for CA65. And again, with that one, it should just hopefully be inject my input and output routines and call it a day, you have basic. I'm kind of personally leaning towards basic just because that was supposed to be like the original point. Like the floppy stuff was almost supposed to be like a stretch goal. And here we are, just because I really wanted to mess with it. But yeah, so I'm leaning towards basic, but you tell me. I'm in fact, since I have to get going, I'm going to make a post on the YouTube social asking which way y'all want to go. But that's where I'm at. I'm leaning towards basic and stopping this whole nonsense. And then when we have basic, we can get back to suffering through the floppy drive. Anyway, I have to get out of here. I gotta eat dinner. All you have a nice night, and I will see you and love ya and bye.